Okay, hi everyone. This is a continuation of the second of the lecture on probability. So the thing we were talking about earlier was if you wanted to find the probability of two events and they are independent, meaning that one outcome has no effect on the other, then all you do to find the probability of A and B is simply multiply the probability of either event occurring. So an example would be find the probability of, and I'm abbreviating, find the probability of rolling a 6 on a regular 6-sided dice, and flipping a tails. So we know the probability of rolling a 6 is 1, right? If we look at the sample space for rolling a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. The event we're interested in is rolling a 6, so that's 1 out of the total of 6. So the probability of rolling a 6 is 1 out of 6. Flipping a coin, we know the sample space is heads or tails, right? If we wanted tails, sorry about that. So if we wanted tails, it's going to be one out of 2. So find the probability of rolling a 6 and flipping a tail. So we take the two probabilities and we multiply them together. You get 1 out of 12. So in our first discussion of probability, we had the probability of A or B. Okay, if we want to find the probability of one or the other occurring. So before we do that, we need to define the following term: mutually exclusive. The term mutually exclusive means that two events cannot happen at the same time. Okay? So let's do an example. Rolling a 2 or a 3. Is that mutually exclusive? Can we roll a 2 and a 3? No. You can't roll a 2 and a 3 at the same time, so these are mutually exclusive. Okay, second example. Rolling an even number or a multiple of 3 on a regular 6-sided dice. Well, the multiples of the multiples of 3 are 3 and 6. Okay, so if we look at the sample space of rolling an even, it's 2, 4, and 6. And a multiple of 3 will be 3 or 6. So since you can roll an even and a multiple of 3, these are not mutually exclusive. Again, so if you look at the outcome of getting a 6, it satisfies both of these. It's an even number and a multiple of 3, so it's not mutually exclusive. Okay, so let's examine a few rules. So if I want to find the probability of A or B, okay, the probability of A or B is probability of A plus the probability of B. This is assuming the events are mutually exclusive. Okay? So if it's not mutually exclusive, if it's not mutually exclusive, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay? So let's do an example. So probability of rolling a 2 or 3. When rolling a 6-sided dice, well, we know the 2 and 3 cannot occur together, so it is mutually exclusive. So we need to find the probability of rolling a 2 plus the probability of rolling a 3. And again, when we roll a 6-sided die, the sample space is this. The outcomes we're interested in are 2 and 3. So the probability of rolling a 2 is 2 out of 1, 2, 3, 4, 5, 6. Again, that's this outcome, that's one outcome out of 1, 2, 3, 4, 5, 6. And the same is for the 3. There's only one of those out of a total possible 6. So that equals 2 over 6, which is 1 over 3. Okay? So let's do another example. Okay, this time we want to find the probability of rolling an even or a multiple of 3. Okay, so let's look at the sample space. The probability of rolling an even which I'll do in red. Even is this one, 2, 4, and 6. And then the probability of rolling a multiple of 3 is going to be this one or this one. So since we can roll an even and multiple of 3, which is when we roll a 6, we're going to have to use the second formula, this one right here. So the probability of rolling an even is 1, 2, 3 out of 6. And the probability of rolling a multiple 3 is 2 out of 6. The one's in blue. And minus the probability of A and B, that's going to be 1 out of 1, 2, 3, 4, 5, 6. 1 out of 6. Okay. So when we add all these up, we get 4 out of 6. 3 plus 2 is 5, minus 1 is 4, which is 2 out of 3. Now, if we had not subtracted this 1 out of 6, we would have gotten 5 out of 6, and intuitively that doesn't make sense, right? We don't have 5 outcomes here. We only have 1, 2, 3, 4. So that's our answer. Okay. Alright, let's work a few more examples. Okay, so let's, 2 standard number cubes are tossed. Standard number cubes are tossed. Okay. State whether the events are mutually exclusive. Okay. One of the numbers is one less than the other. Okay. So that's one event, and the second event is the sum is odd. Okay. So one of the numbers is one less than the other, and the sum is odd. So we're trying to figure out if these events are mutually exclusive. So can they both occur together? So let's just list the possible outcomes here. So here we can have a 1 and a 2, right? We can have a 2 and a 3, 3 and a 4, 4 and a 5, and 5 and a 6. Okay, the sum is odd. Okay, so again, the definition of mutually exclusive is when two events cannot happen at the same time. So we already know when one of the numbers is one less than the other, the sum is always going to be odd, right? It's always going to be odd. This is going to be 3, 5, 7, 9, 11. So these two events always happen together, so they are not mutually exclusive. Okay, another example. The sum is greater than 10, and 6 is one of the numbers. Sum is greater than 10, and the second one, 6 is a number. So why don't we try to list a few examples. So we can have we can have 4, and 6, and then we can have 6 and 6. Right? Sum is greater than 10. So mutually exclusive again means the events cannot happen at the same time. So here 6 is a number here and here, so they are happening at the same time, so they're not mutually exclusive. Okay, hope that clarifies that concept. We're actually out of time again. Thanks for watching.